My name is Stacy. I'm a fifth year in Dan Horton's lab. My talk today will basically focus on my work at Microsoft. This past summer, I had an internship at a Microsoft Research, which is like a branch of Microsoft. It's not the same as the corporation. And specifically, I was working with the urban innovation team. So they're really interested in like smart cities, urban design, those kinds of questions. This is a like philanthropic project because people are always like, what is Microsoft doing with air quality monitoring? And it's basically like a proof of concept, trying to show like how to do it and how to do it like correctly. And honestly, I think it's really amazing the way that they managed to get this project started. There was like no air quality scientists. Like I showed up and was like, yes, the data is okay. And we're all like very excited about that. But here's just like a screenshot of the website. There's over like 100 monitors across the city. And it's basically taking particulate matter and nitrogen dioxide measurements, which are both health hazardous pollutants that I've been studying throughout my PhD. And you might see them, they're on bus stops. They look like this little leaf thing. And yeah, just dispersed all across the city. So yeah, my project specifically this past summer focused on nitrogen dioxide, which is a pollutant that's made from basically like combustion. So it's used as a tracer for basically like traffic. And my thesis has been working with WRF-CMAC, which is a chemical transport model. So I'm getting like atmospheric chemicals, geospatially continuous across the city at a high resolution. But we also have these other air quality data sets, for example, the low-cost sensor network, which is on the end, then also satellite data. So we have all these independent data sets, and then to my horror, they all look great. Like my first like week, I was like, oh my God, none of this data makes any sense. How am I supposed to like truthfully analyze this? Like I really do believe in our model, but I know it's not perfect. And same with these sensors. You can't just like interpolate points and hope for the best. And the satellite has like a lot of missing data too. So basically the way I approached this data analysis was I used a clustering technique. So that way I could focus on like the high impact places, just basically identifying like people want to know where's pollution bad. So I clustered each of these data sets independently and then filtered for the intersection and then came up with basically like high confidence and exploratory clusters. And that's what I have here. Basically like the red hotspot is these are areas we should put in additional monitoring funding and have more like amelioration of air pollution there. I actually found this like weird interaction of like the fact that the sensors were on buses was a huge indicator of like highway traffic. We don't have the sensors on the highways, so we were missing that with the sensor network. And then there was also like in these low areas, doesn't mean pollution isn't bad. You should look at other kind of complementary pollutants such as ozone. And then in the same place, like there were like weird little transient hotspots that the model wasn't capturing. So I think that like further supports having this kind of low cost sensor network. So yeah, that is my talk. In summary, this clustering analysis ended up being really helpful to have kind of a targeted analysis of identifying like where are we confident and where like and why aren't we confident in other areas, and ended up being like very useful. And then this was me at Microsoft this past summer. They gave us a lot of like silly t-shirts. So yeah, I can take questions. Yeah.
This is really interesting. How do you factor in things like wind speed, direction, seasonality? You know, it kind of reminds me of the way back when we had the CO2 monitoring station just on the top of Scott Hall with all these other variables. And like he got into literature about buildings deflecting wind and creating like
Totally.
How do you grapple with that?
Yeah, so that's actually like something really interesting. Some of the other interns were actually focusing more on like daily events, for example, like apartment fires. Like we don't study apartment fires because we don't have the density for that. But that was hugely like where the pollutions ended up. That ended up like just being dominantly like wind direction. You could actually do like a difference analysis where like upwind, you saw the signal, and then downwind, there was no signal. So just like, and literally all you had to do was take the stations for Midway and O'Hare in order to basically figure out where the dominant wind direction was coming from. I think like the 1 to 1 minute interaction, there's like huge variability. But once you begin doing like time averaging, you're getting more of like the actual signal, like the general background pollution, versus like the 1 to 1 minute like spikes that might be due to just random kind of like urban, what do they call it? Urban canyon, kind of like the circulation and that kind of crazy stuff. Yeah, just like longer time averaging slices, better data. And that's what I found for mine. Like my study focused both on like a summer month, August, and then like a winter month, February. And then that way I could just talk about that, like 2 seasons.
That's interesting. Yeah, thank you. It's a really tough problem to work on. Thank you.
Yeah, thank you. Yeah, and if anyone has any questions about like Microsoft or data science, this is very a data science project.